Now I will just highlight the main steps because these steps are extremely important for any kind of linear model. The important steps are, number one, you should draw the black box. You should always start by drawing the black box. That will make it clear what unit or what system you were talking about, if it is a plot or a patient or whatever, and what are the inputs and what are the outputs. Then you take n sets of measurements. So whatever is your system, you take n copies of that. Maybe you use the same thing n times, and you take measurements. And remember, you are measuring all the inputs and the output every time. Then you create a CSV file with all those things. If your box is like this, k inputs and 1 output, there are k input columns, 1 output column, so there are k plus 1 columns in your file and n rows in your file, excluding the very top line which gives you all the names. And I would always suggest that you make it a CSV file. That means that you separate them with commas. They will make your life a lot easier. So make a comma separated file, and there are n many such lines. Then you load this file in R, dat equal to read.csv, whatever is the name of your file, put it inside quotation marks. Then you should check the sanity of the data set, that is whether you have really read the right thing, check the names, whether the same columns as you have wanted, the appropriate number n and the appropriate number of columns, look at a few first observations, etc. Whenever you load a data set, check the sanity of that. Then you should plot out against the different inputs. It just depends on the particular problem, which plot you think is meaningful. Try to explore. There is no hard and fast rule for that. Try to make box and whisker plots, try to make scatter plots, etc. We shall see more examples of this later. Then you actually carry out the fit. You can use whatever variable name you want. I am using fit equal to lm out, then tilde. In this ... you have to write whatever appropriate model you try to fit. In our case, we just fitted linear regression, so we just wrote the name of the input. We shall see more variants of that. Then write comma dat, that is the name of the data set that you have used. This name is optional. You can use some other name also, just make sure this is same as this name. Once you get the fit, you should explore that, look at what are the estimated coefficients, etc. There are various ways of exploring. We have seen basically a few. We have seen how to find the coefficient, the residual, the fitted values, etc. Finally, and this is of crucial importance, you should assess the goodness of fit. Just because you have applied least squares method does not mean that the model is a good fit. It gives you the best possible thing, but if the model itself is very bad, then even the best estimated coefficients will not save the day. So you should assess the goodness. The simplest technique is to plot the fitted value with the original output thing, or just as we did, we just took the scatter plot and drew the line on top of that. There are lots of different ways by which you can assess goodness, but remember that you must do that. If you are happy, fine, your analysis is over. In practice, most of the time you will not be happy with the goodness of the very first fit that you get. In that case, you will go back to step 7, you will tweak this thing and again keep on doing 7, 8, 9 repeatedly until you are finally satisfied. So make sure you understand this workflow clearly, because we will be doing this again and again all throughout this course.